Okay, Algebra 1, this is Miss Reeves. I'm not going to be in class today because I'm testing. So what I'm going to do is work a couple problems from your homework, those last two word problems for you. After you have finished those two problems, then you need to turn in the 5-4 practice to the substitute. Then you're going to start taking notes from this video as well, and you need to copy down the problems like we normally do in your composition book and follow along. When you have finished your notes, you can go ahead and start the 5-5 practice, which will also be your homework today. Okay, so number 15 says that strong winds called the prevailing westerlies blow from west to east in a belt of 40 degrees to 60 degrees latitude in both the northern and southern hemispheres. They want us to write an inequality that represents the latitude of the prevailing westerlies. So they're saying that these westerlies exist between 40 and 60 degrees. So if I'm writing an inequality that is between 40 and 60 degrees, I can write it this way. I'm going to go ahead and put 40 and 60, and then the variable, you can use x or whatever letter you want, goes in the middle. And we're saying that x is between 40 and 60 degrees, and it can equal these values also. So when I'm reading from the x to the left-hand side, x has to be greater than or equal to 40 when you're reading from the x. If I was reading from the 40, then it says 40 is less than or equal to x. Okay, then for the other side, x has to be less than or equal to 60. So we're saying that x can be anywhere between 40 and 60 and can actually equal 40 and 60 also. Part B says to write an inequality to represent the latitudes where prevailing westerlies are not located. So that means we need to write an inequality that would be the complete opposite of the inequality that I wrote for Part A. So if it's the complete opposite, then I'm going to write it two different ways. Since we said earlier that x has to be greater than or equal to 40, then I'm going to say x has to be less than 40. That would be the complete opposite of the first part. Or we could say that x has to be greater than 60. So we're saying that the degrees could be anything less than 40 or anything above 60. That would be the complete opposite of Part A. Okay, so number 16 says that a cookie contains 9 grams of fat. If you eat no fewer than 4 and no more than 7 cookies, how many grams of fat will you consume? Okay, so they're saying that we're going to eat between 4 and 7 cookies. So I'm going to start with the 4. And since we said they are 9 grams of fat each, that's going to be 9 times 4. Then I'm going to put my x. I'm going to leave a space. And then the most cookies that we would eat is 7 cookies. So that's going to be 9 times 7. Okay, so we're saying that we're going to eat more than or equal to 4 cookies and less than or equal to 7 cookies. So we're going to go ahead and multiply 9 times both of these to find out the number of grams of fat. So 9 times 4 is going to be 36 grams of fat, which has to be less than or equal to x. Less than or equal to 9 times 7 is going to be 63 grams of fat. So if you eat somewhere between 4 and 7 cookies, and that could equal 4 cookies or equal 7 cookies, then you could eat between 36 and 63 grams of fat, depending on the number of cookies that you ate. And it could equal 36 grams of fat, or it could equal 63 grams of fat. Okay, so you need to make sure that your name is on this paper and go ahead and pass those into the substitute. You can pause the video now. When you unpause, I'm going to start the notes for 5-5. Okay, now we're going to look at the notes for Section 5 on inequalities involving absolute value. So we're going to be solving inequalities that have absolute value in them. Remember that absolute value, there's always two options when you're doing the absolute value. Two things that you could plug into the absolute value that would make it positive. The answer of an absolute value of anything is always a positive answer, but I could take the absolute value of a negative number and it would be positive. I could take the absolute value of a positive number and it would be positive. So there's always two cases that we're looking at when we talk about absolute value. Okay, so this first thing says that to solve an inequality in the form absolute value of A is less than B, where A represents a variable expression and B is a number greater than 0, you're going to solve the inequality negative B is less than A less than B. And the way I'm going to do it is a little bit different than what is written here. We're actually going to solve two inequalities, and when we get to the example, I'll show you. So anytime you see the absolute value of an expression, we're going to solve two inequalities. Okay, so go ahead and write down this example. The absolute value of n minus 3 is less than or equal to 12. Okay, the first thing we're going to do is solve the inequality just by dropping the absolute value bars. So I'm going to go ahead and rewrite the inequality just like it is, but without the inequality bars. So n minus 3 is less than or equal to 12. Okay, so we're going to solve this inequality the same way that we've solved them the last couple of days. I'm going to start by adding 3 to both sides. So my negative 3 and positive 3 are going to cancel out. I'm going to have n is less than or equal to, then 12 plus 3 is 15. So one possibility is that n is less than or equal to 15. And we'll graph that in just a second. The other part of this problem that we need to do is the opposite of the inequality that is given to us. Okay, so what I mean by that is we're going to take what is on the left-hand side, I'm going to put that in parentheses, n minus 3, and I'm going to put a negative in front of it. So it's the opposite of whatever was on the left-hand side. And then is less than or equal to 12. So now we're going to solve this inequality. And you can do this several ways. I'm going to go ahead and get rid of the negative in front of the parenthesis. I'm not going to distribute. I'm going to divide by negative 1 on both sides. Remember the rule that when we divide by a negative on both sides of the inequality, it's actually going to flip our inequality symbol over. So on the left-hand side, I'll be left with n minus 3 again. On the right, 12 divided by negative 1 is going to be negative 12. So what actually happens from my original problem is you could also think of it that you flip the inequality and change the sign of the number on the right-hand side. Okay? So now we're going to go ahead and solve this problem by adding 3 to both sides again. So on the left, this is going to be cancel, and I'll be left with n is greater than or equal to. This time, negative 12 plus 3 is going to be a negative 9. Okay, so now I'm going to make a number line so that I can graph both of these on the number line. Okay, so I've gone ahead and made my number line, and I didn't fill in all of the numbers, but I made sure that I had some numbers around negative 9, that's my smallest number, and I made sure that I had some numbers around positive 15, which is my biggest number. And then we know that 0 should be somewhere in the middle there. So I'm going to start with my smaller part of my inequality, which says that n is greater than or equal to negative 9. So I'm going to go to negative 9 on my number line, and I'm going to do a closed circle since it's equal to. And then since it's greater than, then I'm going to start drawing my line to the right. Okay, I'm going to pause there for a second and do the other side. So it says that n is less than or equal to 15. So since it's equal to on 15, I'm going to do a solid circle. And then less than means that I would shade to the left. So we can see here that we have the intersection of these two. So it can be either -9 or +15 or any number in between. Okay, our next option says that to solve an inequality in the form absolute value of A is greater than B, where A represents a variable expression and B is a number greater than 0, we will solve two separate inequalities. One where A is less than negative B, or one where A is greater than B. So in the last example, since the inequality was less than a number, the answers that we had were an intersection or an AND problem. Since this one says greater than a number, this is going to be an OR problem. So I'm going to start the same way. I'm going to have one inequality that's exactly the same as the inequality that they gave me, just dropping the absolute value bars. And then, or we're going to solve this problem where we're going to do the same thing. We're going to change the sign or put a negative in front of the left-hand side. And we'll solve this problem as well. So again, we're doing two inequalities. This one will be an OR because it starts with a greater than. Okay, so I'm going to solve the problem on the left first. We're going to add 3 on both sides. So now I'm going to have 3y is greater than 9 plus 3 will be 12. Then we're going to divide by 3 on both sides. So y is going to be greater than 12 divided by 3, which is 4. Okay, now we're going to go over here and solve the second problem. The same step that I did the first time on example 1 was I'm going to divide by -1 on both sides. So on the left, we're going to keep our 3y minus 3. Because we're dividing by a negative, that's going to flip our inequality, and 9 divided by a -1 is going to be -9. So we're going to add 3 to both sides. And this will give me 3y is less than -9 plus 3, which will be -6. We're going to divide by 3 on both sides. So y will be less than -6 divided by 3 will be -2. Okay, so I'm going to draw my number line for these, and since these are an OR problem, these will probably go in opposite directions. Okay, so I've made my number line. Always make sure that you have the numbers that are included here, -2 and 4, and then some numbers on either side of those. So I'm going to start with my smallest one, which says that y is less than -2. So I'm going to go to -2 and draw an open circle. And since it's less than, we're going to shade to the left and draw an arrow. My other inequality says that y is greater than 4. Since it's just greater than and not equal to, I'm going to have an open circle, and then I'm going to shade to the right. Okay, so we can see here that the answer could be anything from -2 to -infinity, or it could be from +4 all the way to +infinity, but not including -2 or +4 and nothing in between those two. Okay, so example 3 says the absolute value of 2x plus 7 is greater than 11. Okay, so we're going to rewrite our inequality. 2x plus 7 is greater than 11. And since this is greater than, We are also going to do the other equation, changing the sign, so it would be negative parenthesis 2x plus 7 is greater than 11, and we're going to solve both of these, and then we'll graph them simultaneously. So I'm going to start on the left-hand equation, and I'm going to subtract 7 on both sides. So this will give me 2x is greater than 11 minus 7, which is 4. Then we're going to divide by 2. So then x is greater than 4 divided by 2, which is 2. Okay, now we're going to go to the other equation, and I like to get rid of the negative first, so we divide by negative 1 on both sides. So on the left, this is 2x plus 7, and because we're dividing by a negative, we're going to flip our inequality, is less than negative 11. So we're going to subtract 7 on both sides. So 2x is less than negative 11 minus 7, which is negative 18. We're going to divide by 2 on both sides. So now x is less than negative 18 divided by 2, which is negative 9. Okay, so I'm going to draw my number line. So on my number line, I want to make sure that I have numbers to the left of negative 9 and to the right of positive 2, and then numbers some in the middle. So we're going to start with x is less than negative 9. So since it's less than negative 9, this is going to be an open circle at negative 9, and we will shade to the left. Then for the other part of the inequality, it says that x is greater than 2. So I go to 2, and this will be an open circle at 2, and we will shade to the right. So for this absolute value inequality, x could be anything less than negative 9, and it could be anything greater than positive 2. Okay, this will be our last example. So I have the absolute value of 5x minus 1 is less than or equal to 2. So we're going to start by writing the inequality just by dropping the absolute value bars. 5x minus 1 is less than or equal to 2. Then we're going to write the opposite. So I'm going to write negative 5x minus 1 is less than or equal to 2. So I'm going to start by solving the inequality on the left. I'm going to add 1 to both sides. So this will make 5x is less than or equal to 3. Then I'm going to divide both sides by 5. So then x is less than or equal to 3 divided by 5 will not simplify or reduce, so I'm just going to leave that as 3 over 5. For my other inequality, I'm going to get rid of the negative first by dividing by negative 1 on both sides. So the left-hand side will stay the same, 5x minus 1. Because I'm dividing by a negative, the inequality will flip over. And 2 divided by negative 1 will be negative 2. I'm going to add 1 to both sides. So 5x is greater than or equal to negative 2 plus 1 will be a negative 1. We're going to divide by 5 on both sides. So x is greater than or equal to negative 1 divided by 5 does not simplify or reduce, so it will just be negative 1 over 5. So now we're going to make our number line. So I've made my number line, and I have put negative 1 on the far left, 0 in the middle, and positive 1 on the far right. And then I have 5 lines in between each of them. Oh, whoops, let me fix that. I should have 5 and I actually have 6. Okay, so the reason for having the 5 lines is because I'm splitting this up into fifths. So, for example, between 0 and 1, each of these is 1/5. So this would be 1 over 5, 2 over 5, 3 over 5, 4 over 5, and then 1 is the same as 5 over 5. And I know that's kind of hard to read. And then going the opposite direction, same thing. This would be negative 1/5, negative 2/5, negative 3/5, negative 4/5, and then negative 5/5 is negative 1. Okay, so I'm going to start with the smaller number, which is x is greater than or equal to negative 1/5. So negative 1/5 is going to be the first mark to the left of 0. So since it is greater than or equal to, then I'm going to do a solid circle, and then I'm going to be shading to the right. And I'm going to pause right there while I shade. The other part of this inequality said that x is less than or equal to 3/5. So I'm going to go to the third mark on the right-hand side of 0. And since it said it could be equal to, I'm going to do a solid circle, and then I would be shading to the left. So it can be negative 1/5 or 3/5, and then any number in between those is a solution as well. Okay, so now the substitute is going to pass out your 5-5 practice, and you need to start working on it. Whatever you don't finish in class will be homework, and I will answer questions in class on Wednesday.